Okay, for this video, we'll be going through light success criteria C. Recall and use the terms of refraction, including normal, angle of incidence, and angle of refraction. So we have covered reflection in the previous two videos. Now we'll be going through refraction. Okay, take note of the spelling. We still have normal, which is very important. Now, normal is a imaginary line that is perpendicular to the surface. Okay. We have angle of incidence, which is the angle between the incident ray and the normal. We have now angle of refraction, which is the angle between refracted ray and normal. So as you can see, the normal is very important. Okay, and again, normal is an imaginary line that is perpendicular to the surface. Okay, just to recap, if I have a surface like this, the normal should be drawn like this. Okay, so it must be perpendicular to the surface. Now, light travels at different speed in different optical media. What is optical media? You can think of them as transparent material. So example would be your glass. It can be water. It can be oil. It can be plastic. A see-through plastic. Okay, now for example, the speed of light in air is about 3 times 10 to the power 8 meter per second. I know this is the speed of light in vacuum, 3 times 10 to the power 8, but for air it is quite close to these values. Okay, in water it is 2.2 times 10 to the power 8, and in glass is 2.0 times 10 to the power 8. Okay, you only need to know this. The rest will either be provided to you, or you will have to do calculation to find it. Therefore, because of the difference in the speed of light, at the boundary of the two optical media, there will be a sudden change in the speed of light. And this will cause the path of light to bend. Okay, now what is refraction? It is actually the bending of light when it travels from one optical medium to another. This is the definition. It means it is the what. So why does light bend? Is because of the change in speed of light. Okay, so this is the reason why light bends. Okay, so I need you to memorize this LDDT. It actually stands for less dense to denser, bend towards where? Towards the normal. Normal is very important. So LDDT. So means if the light is traveling from a less dense medium to a denser medium, it will bend towards the normal. So let's do some practice here. Now, air and water, we know that air is less dense. Okay, water is denser. A very quick way to determine whether is it less dense or denser is put yourself in that medium. Do you think you can move faster in air or in water? Okay, so air is the less dense medium. Water is the denser medium, and through this arrow, the path, we know that is going from less dense to denser. So you can apply LDDT. That means the light ray will bend towards the normal. So first of all, we need to draw a normal. So the normal is a dotted line, imaginary line that is perpendicular to the surface. Now that's the first step. Second step is we can continue drawing the light ray as if it hasn't bent. Okay, as if it didn't bend. Then we apply LDDT because it's going from less dense to denser. So this is the original path. So it's going to bend towards the normal. So the normal is here. It bends towards the normal. So this will be the refracted ray. Okay. So this will be my angle of incidence, and this will be my angle of refraction. Now, how about if the light ray is going from water to air? So again, we determine which one is the less dense, which one is the denser. And as you can see from the arrow, it's traveling from denser to less dense. Now, if less dense to denser is towards LDDT, that means denser to less dense, it must bend away. So again, we have to draw our normal. Okay, so this is our normal, and we draw the original path. Once you get the hang of it, you may not need to draw the original path already. Okay, so we know that it's going from denser to less dense, it must bend away. So something like that. This will be the refracted ray. Okay, and this is my angle of incidence, and this will be my angle of refraction. Always take the angle of incidence or refraction with the normal as the reference. Okay, Now make sure that the normal is always drawn, very important. Extend the light ray with a straight dotted line to show the original path if there's no difference in medium. Then apply LDDT to draw the path of refracted light ray. Okay, so some of the terms that we need to know. So this one is my incident ray. This is my point of incidence. Okay, so fill in the blanks for this. You have point of incidence similar to what we had in reflection, but now we have refracted ray. We have now angle of refraction. Take note that the angle is always between the ray and the normal. Okay, so where's our normal? Now take note, every time the light reaches a new surface, okay, you always need to draw a new normal. Now this is our emergent ray. The emergent ray is sort of, you can think of it as, because the light is traveling from air to glass, and after that it will emerge from the glass into air again, so we can call it the emergent ray. But I can also, if I just want to look at this part, I can say that this is the incident ray. Okay, I can take this surface as the new surface. This is incident ray, and then this will be the refracted ray. Okay. Okay, light can also be seen as a wave, right? We have learned that in EM spectrum, visible light. So the distance between wavefronts can be shown to change as light travels to a different medium. So all these lines are your wavefronts. Okay, so what happens when it enters from a less dense medium? Let's say this is air and this is glass, right? Okay, we learned that air is less dense, glass is denser. Okay, so LDDT, right, it should bend towards the normal. So where's the normal? The normal is drawn at the point of incidence here. And you see that the light ray actually, if there was no bending, this is the original path. We see that the light ray actually bend towards the normal, right? So I just want to test you on this, because you see this is the wavelength, right? This is the wavelength. So we see that the wavelength actually gets shorter, right? The wavelength gets shorter, so shorter wavelength. So we learned in our previous chapter of waves of SSSS, shorter wavelength, then it will be slower speed, correct? Slower speed. So you do see that the wavelength becomes shorter because the speed changes from 3 times 10 to the power of 8 meter per second in air to roughly 2 times 10 to the power of 8 meter per second. Okay, so based on your understanding of waves and SSSS, is the light speeding up, slowing down? So it is slowing down.